Professionals in the genetics field generally support editing the genomes of somatic cells, mirroring public opinion, but diverge from non-experts when it comes to germline editing. Wikimedia. Zephyrize. With the advent of technologies such as CRISPR-Cas9, genome editing has shot to prominence both in the life science laboratory and on the ethical radar screens of the general public and bioethicists alike. As researchers report successes in using precision genome editing on somatic and germline cells, a new survey of attitudes among genetics professionals indicates that people working in the field have views that differ in important ways from opinions held by the general public. There is a need for an ongoing international conversation about genome editing, but very little data on how people trained in genetics view the technology, says Alyssa Armsby, who led the research as a graduate student in the Stanford University lab of geneticist Kelly Ormond, in a statement. As the ones who do the research and work with patients and families, they're an important group of stakeholders. Armsby, Ormond, and their collaborators queried 500 genetics professionals culled from large, professional organizations from around the world, including the American Society of Human Genetics, the Human Genetics Society of Australasia, and others. Of these respondents, about 55% worked as clinicians or genetics counselors and about 30% were laboratory researchers. Presenting their preliminary data at the American Society of Human Genetics annual meeting in Orlando last week, October 19, Ormond said that there was overall support for genome editing in basic research contexts, but that this support fell off when the respondents were asked about clinical uses of the burgeoning technology. For example, when asked if they were supportive of basic research on human somatic cells, about 99% of respondents said yes. But only about 87% of respondents said they supported clinical research on human cells for the development of somatic gene editing applications. There were also key differences between the professionals she and her collaborators queried in a previous survey of public opinion on genome editing. Our group found higher acceptance of somatic genome editing in all areas than the public study, and more difference between the professional support for somatic and germline editing, she writes in an email to The Scientist. Also, the public seemed more accepting of enhancement in both somatic and germline than our data showed. Ormond and her colleagues found that about 70% of survey respondents were strongly supportive of the use of somatic gene editing for the purpose of treating a genetic condition causing a physical disability. Only about 40% of survey respondents expressed strong support for germline gene editing for the same purpose. In a previous survey of the public, approximately 65% of respondents said they saw either somatic or germline gene therapy as acceptable. These results may indicate, Ormond adds, that increasing knowledge of the scientific realities and challenges involved with precision genome editing may modulate acceptance of the use of such a new technology in a clinical setting. As people become better educated about genome editing, they're able to use that information to flesh out their opinions, and surveys can start to reflect more nuance in why people believe what they do, Armsby says. The researchers suggest that some demographic factors may influence the opinions of genetics professionals on the application of genome editing. For the professionals, age, years of experience, and degree of religiosity were the most associated factors with support for both somatic and germline gene editing, Ormond writes. Similar connections to demographic factors hold true among members of the public asked similar questions about the technology. Processing. Researchers identify 72 novel genetic variants associated with breast cancer risk. Plantings of Nongam refuges counter the development of resistance. The EPA is now in charge of regulating the use of Oxitec strain of Aedes aegypti, genetically engineered to reduce populations of the insects.